Hello students, welcome to YourPedia platform. My name is Arun Pathania and today in this video I have brought to you a descriptive solution of one of the questions which was asked in NPTEL assignments for the subject of structure analysis and the branch civil engineering. As we all know that NPTEL assignments questions are very important from the GATE point of view, so I hope that you will listen to this video very attentively. So let us just look at the question, try and solve it. So the question is, it's a linked question. We have to find the horizontal reaction at the support B. Here we have to find the horizontal reaction HB, and we have been given the details of the member, like we have been given the modulus of elasticity and the area of each member of the truss, and it has been specially written that diagonal members are not connected. So we get a joint here, here also, and this point also, this point also. This is not a joint. This is what I want to tell you, this is not a joint. So there are 5 members and 4 joints. And the second linked question is we have to determine the member force in the AC member. So in this member basically we have to determine what is the force in this member, actual force in this member. Now we have given some options also. Now basically finding force in a member of a truss is very easy. You know, we can find the support reactions from the available equilibrium equations, and we can use the method of joints or method of section, and we can find the force in that member. But this truss is not that easy. Why? Because here if you closely notice, the supports are both hinged. Okay, it's not a hinge and a roller support. It's not a statically determinate truss. It has 4 reactions. If you closely look, it has 4 reactions. It has 4 reactions, jabki the available number of equilibrium equations are 3 only. So if you look from the formula of statical indeterminacy, we have number of unknown forces minus known equilibrium equations. So number of unknown forces is basically the number of members, because every member will have one unknown force, the axial force that is in that member, and the number of support reaction. And what are the known equilibrium equations? At every joint we have 2 equilibrium equations which are known to us. So if we go by that formula, we have like 5 members and support reactions are 4 and the joints are 4. So we have into 4, so we have the degree of statical indeterminacy is basically 1. So this structure is basically statically indeterminate. Now we have to check whether it is externally statically indeterminate or internally statically indeterminate. So we have to find the external statical indeterminacy also, which is number of support reactions minus available number of equilibrium equations. In this case, the available number of equilibrium equations are 3 only. So I have directly written 3. So here we have number of external reactions are basically 4. So 4 minus 3, we have 1. So it is externally statically indeterminate to 1 degree. So total statical indeterminacy is 1 also, external statical indeterminacy is 1 also. So internal statical indeterminacy is 1 minus 1 is equal to 0. So this truss is not internally statically indeterminate, it is externally statically indeterminate, means it has an extra reaction. So the redundant force that we are going to choose is going to be one of the reactions. All the member forces are okay, we don't need to choose a member force as the redundant, we have to choose one of the support reactions as the redundant. So in order to solve this, what we are going to do is we are going to use the method of superposition. Okay, we are going to choose one of the support reactions as a redundant force and analyze the whole truss without that redundant force first, and then analyze the whole truss with that redundant force but without the external force, and we are going to combine both the results. So let me show you that diagrammatically. So this is the method of superposition that we are going to follow here. So what we have, this is basically our given truss with 2 hinge supports, an external loading of 25 kilonewton. What we are going to do, we are going to break it into simpler components. First we have this statically determinate truss which have only 3 reaction and external forces also applied here. And then another component will be that same statically determinate truss, but now only redundant force is basically acting, the extra support reaction that we have, only that is acting, and no external force is acting now in this case. So when we combine both these results, we get the result for our statically indeterminate truss, which was basically asked in the question. So let us just say that this system of loading, this condition of loading is P system of loading. Okay, so whatever the force in each member in this case will be designated by P term. So like in member AC, the force under such condition will be PAC. Okay, and this condition, this loading condition, we are going to denote by P dash system of loading. So under this loading condition, the forces any member will be designated by term P dash. So force in member AC will be designated by P dash AC. Under this loading, where only redundant force is acting, any forces any member will be designated by R symbol. So basically the force in member AC under this system of loading will be designated by RAC. So basically, according to the method of superposition, we have the force in member AC under our real condition loading condition, under P loading condition, is equal to force in member AC under P dash system of loading plus force in member AC under R system of loading, our redundant system of loading. So this is basically what we have derived. In general, we can also write the force in any ith member under P system of loading is equal to force in any ith member under P dash system of loading under this statical determinate structure, okay, plus force in any member under R system of loading. Okay, so in this way we break this complex question into these simpler components, and these simpler components can now be analyzed and the results can be superimposed to get this result. Okay, this is what we have done. We can make this question convenient to and easy to solve. Now what we have, this we can analyze, okay, because force is given, we can find the support reaction, we can find the forces in member also. But if you closely look, this is not yet solvable. Why? Why? What is the reason? Because the value of R is not fixed. This redundant force can have any value. It can be 10 kilonewton, it can be 20 kilonewton, it can be 100 kilonewton. So unless it is fixed, the support reactions are not fixed, the member forces are not fixed, and if we don't have the direct value, we can't superimpose both the results. So we need to fix this redundant force first. So what do? We basically do this. We apply superposition principle, but this time we use the concept of linear elastic system. So if I have a cantilever, for example, and if I apply like 1 kilonewton of force over it, it will deflect by some amount, say A amount, and against that same cantilever, if I apply 10 kilonewton force, it will deflect by some amount. Now if this system is linearly elastic, which according to assumption all our structure in structure analysis are linearly elastic, only then Hooke's law is valid. So their deformation, elastic deformation, are linearly dependent on the loading. If loading is increased 2 times, the deflection will also be increased 2 times. Okay? There is a linear relationship between them. So according to that linear elastic relationship, B must be 10 times greater than A. So same happens in this case also. If I have this structure and suppose I am applying R force, so whatever member forces will develop, that will be equivalent to if I take the same truss and apply a unit load in that same direction, and now I have member forces, and now I multiply each and every member forces by R amount. Suppose this R was 10 kilonewton. Okay, but I have applied 1 kilonewton here. Now if I get in this member, the force comes out to be suppose 0.2 kilonewton. So what is the actual force in this member here will be 0.2 into 10 will be 2 kilonewton. So this is the linear elastic principle and superposition principle we are applying simultaneously. So we can find this now is very easy to analyze, because 1 kilonewton is a definite value. We can find the support reaction, we can find the member forces, and then we can multiply those member forces with R value, and we can find the forces under this condition when R kilonewton of redundant force is actually acting on this support. Now still we don't have each and everything, because now R is still unknown to us. We don't have the value of this redundant force. Now how can we get the value of this redundant force? What we will do is, So we here like the previous relation that we derived in a previous slide is basically a force in any member under P system of loading will be force in any member that under P dash system of loading, plus now we have this thing, force in that member under unit loading multiplied by the value of redundant force. Now we still need to find the value of redundant force. How will we find that? For that we will use the principle of minimum strain energy. Now what this principle of minimum strain energy says, but before that we must know the okay, this is the principle of minimum strain energy. Now what does it say? It says that out of the infinite possible values, the redundant would take that value for which the total strain energy of the whole system would be minimum. So this is very important line. It says ki the redundant can take any value, you know, out of infinite possible value it will, but it will take only that value for which the strain energy of whole system would be minimum. This is analogous to maybe if you have read in your 11th or 12th class, we have read that lower the energy of the electronic configuration, higher is its stability. तो जितनी उसकी energy कम होगी उतना ज़्यादा वो stable होगा. तो this is same, जितना उसका strain energy कम होगा उतना ज़्यादा उसके chances हैं कि the redundant will have that value. So first we need to find ki how do we find the strain energy of the whole structure. Now we know this principle, but we need to know how to find the strain energy of the whole truss, whole structure. So for that first we need to know how do we find the strain energy of a particular member. So in case of a truss, the members are only under the action of axial force. So when a member is under the action of axial force at time t, when 0 kilonewton load suppose is acting, no load is acting, the deformation is 0. But after some time the suppose P force is acting, P force axial force is acting, so the deformation is basically what? Delta deformation has occurred. So strain energy in this member under P dash loading will be called as average load into deflection. So what is average load? In beginning it was 0, in the end it was P divided by 2 into the deflection. Now deflection, as we know, we can write in this form. If we can write the deflection in this form. So strain energy of this member under axial loading becomes this. Now we want the strain energy of the whole structure, not only single member. The whole structure is under axial force only. So the strain energy of all members becomes this. We find the strain energy of every member and then we add them. This is what it symbolizes. Now I have this. Now coming back to that same principle कि redundant जो है वो it will take that value for which the whole strain energy would be minimum. Now how can we represent this mathematically? We can write that the partial derivative of total strain energy with respect to the redundant would be equal to 0. Now what is the total strain energy? We will substitute this value which we derived in the last slide, that summation of P square into L divided by 2 AE. The derivative of this would be equal to 0. Now we will solve this. While solving this, what we will see that we we apply the power rule over here. So this comes outside and we have this, and then we again find the derivative of this particular thing. Now P dash is constant for with respect to R, so the derivation would be the derivative would be 0, and for RU when we do the differentiation with respect to delta R, this will become U only. So answer for this is U, and this is common that we have यहाँ से जो था वही हम लोग नीचे लेकर आए, and when we multiply this to this we become P dash into U into L upon AE, P dash into U L upon AE, and we have R U square L upon AE, R U square L upon AE. The sum of this will be equal to 0. Now what are these terms? Let me explain these terms again to you. P dash is basically like for every member we have P dash. When we static P dash system of loading is what? When statically determinate हमने truss बनाया था, only external forces acting. So in whatever member we are saying, suppose AC member we are taking, so we can find this P dash. This is the force in AC member, and then U, when only unit load is acting, external forces are acting. What is the force in member AC? So force in member AC, you have length of the member AC, area of the member AC, area the modulus of elasticity of member AC. Now this for all member, for AD, AC, AB, all these members, and then we find the summation. So this is that term. Now what happens in the second term? Second term we have the value of redundant, and we do find the value of the force in member AC under unit loading, we squared it. Okay, we square it, then we multiply it with the length of the member AC, then divided by the area and the modulus of elasticity of member AC, and then we find it for all the terms, we sum it and we find this value also. So this value have, this value is have, now still R we don't have. So why are we doing this? ये हम लोग कर ही इसलिए रहे हैं so that we can find the value of R. So what we are doing, so यहाँ पर हमारे पास अभी तक ये टर्म बना, इसको हम लोग जीरो के इस तरफ ले गए, then here from here we can find the value of R. From here we can find the value of R, because this term we can find out, this term we can find out. So for the truss member, for different configuration, we find these terms and we get the value of R. And if we get the value of R, what we do? हम क्या करेंगे? We find the value of R over here. We already have this value, we already have this value. Now we can find the force in any member. So ये सारा हम लोग कर किस लिए रहे हैं? We are doing this so that we can find the forces any member. We have to find the force in member AC na. So we have to find this force in member AC under P dash system of loading when only external force is acting and the truss is statically determinate, and then we find the force in member AC when only unit load is acting and external force is not acting, and we can also find the value of R through that process which I already explained through strain energy differentiation. And this we can find the force in member AC under this this loading, which this under this condition, actual condition, we can find the force in member AC, and this is what we want to find. Okay, so let's move on for now. This is theory I have already explained. This is the theory behind this. Now we are going to do the numerical part. You know, we are going to find the actual values, and now you will see ki what we did. Okay, so this was theory part. It might look like a lot of concepts are being used. It might look confusing to you, but if you like try to understand it nicely, then you will get it. So if you don't get it, you can rewind the video and you can listen to that again. Okay. Now what we are doing, now we are analyzing the structure. First we have to find the forces, member forces under, because for finding the value of R, what you have to do, you have to find the force in each and every member under P dash system of loading. What is P dash system of loading? When external forces acting and that redundant is not acting. Then you also have to find the U value, which is basically when only unit load is acting and external force is not acting. You have to find forces in each member also for this thing. ये भी है, L you already know, A and E you already know, so you don't need to find that, but for this you need to find the member forces in for each member under P dash system of loading, under unit loading. Okay, so first under P dash system of loading, when only external force is acting and redundant is not acting. Now you can find the value of reaction by using the equilibrium equation. By summation of Fx is equal to 0, we find the value of HA, and it comes out to be minus of 25 kilonewton. Okay, then if you see we have to find this value of theta also, because this theta is not given to us and we need to resolve the forces later on. So let me find the value of theta. We can have, like, this is 8, this is 6, so tan inverse 6 by 8, we get theta around 37 degrees Celsius. So cos of 37 degree will be almost 0.8 and sin of 37 degree will be equal to 0.6. We will use these values later on. Now we are finding the reactions. So HA हम लोगों को already पता है. Now we use the summation of Fy is equal to 0. We get Va plus Vb is equal to 0. But still अभी हम लोगों को आगे नहीं मिला. So we need to use third equation also. Third equation is summation of sum of moments about the point B is equal to 0. Now what are the moments we have to take? So VA is basically clockwise moment. VA will give clockwise moment, so basically it's positive and its perpendicular distance is 8 meters. So VA into 8 and then we have another force. HA will not create any moment about point B because the line of action is basically same. VB will also not create any moment because the line of action is same. But this 25 kilonewton can create moment. How much moment will it create? It will create, we'll see, it is creating a clockwise moment, and the perpendicular distance between them is basically this 6 meters. 6 meters is the perpendicular distance. So what I have written is VA into 8 plus 25 into 6, because both clockwise, so I have to take the same sign, is equal to 0. From here we get VA is equal to minus of 87 kilonewton. So since the sum of VA and VB was 0, so VB will come out to be 18.75 kilonewton. Okay, we have found the reaction. Now we can find the member forces by using the method of joint, and I can give you an example. For example, at joint A, what I did at joint A, I saw ki these two members are going on. FAC is there, FAD is this side, minus 25 kilonewton, HA is acting, minus of 18.75 VA is acting, and I resolved this force into these two components, and then I again applied equilibrium equation. So I did the this is basically what I did is FAD cos 37 degree, which was 0.8 FAD, 0.8 FAD is equal to 25 degree, is equal to, I added both these. I did the summation of Fx is equal to 0. From here I get the FAD. Then I did this, this summation of Fy is equal to 0. From here I get the value of FAC, which was 0 kilonewton. Now this A joint is complete. Next we will move on to joint B. Similarly, here also I found the value of FBC and FBD by using equilibrium equations only and resolving any inclined force. Okay. Similarly, at joint C, the same process is being done, and from here I get the value of the member forces. All the 5 member forces, I got the value under that P dash system of loading, where only external force was acting and redundant was not there. It was a statically determinate truss. Now we have to find the member forces under our system of loading, not our system of loading, basically U system of loading we have to find under unit loading. So when only redundant forces acting and external forces are removed. So in this case only unit load we will apply, because we already have seen how we convert this unit load into our system of loading. Okay. So what we have the same truss. Now a unit load is basically acting in direction of the redundant force. Again we find the value of HA and VA, VB, which comes out to be 0 kilonewton. Okay. Then we, like we did earlier, we use a method of joints and we find the member forces in each and every member under that unit loading. This basically gives me the value of UI. That UI value is basically this, and that P dash I value was this. This was P dash CD value, P dash AB value, that was P dash value. Okay. For all members, I got this. So this this is my truss, and when I solved this, I got these values. Now what I have to do, I have to find the value of R. And how can I find the value of R? Why am I doing this? I am doing this because I have to find the value of R. This R is basically HB, so I need to find the HB. For that I need to find the value of R, and for value of R I need to find these things. P dash I have found, U I have found. Now I have to make a table and find the summation. So that's what I am doing. I have made this table where I have listed all the members AC, AD, CD, BD, their length I have taken from the figure, and then I have listed what is the value of the forces in these member when only external force was acting and redundant was removed under P dash system of loading. Under unit loading I have also written AE value is constant, so there is no need to substitute it. I can directly write AE, and then I have found this value ki when I multiply this into this divided by length, multiplied by length divided by AE, what is the value I get? I get 0 value. For this member, this value. For this member, this value. I have done this, and then I have found the summation. What is the sum for each and every member? Again, I have found for U square L upon AE, I taken U, I squared it and then multiplied with length and divided by with AE, I get this. And for all members, I have found the summation. Now I have this summation, I can easily find the value of redundant now, which I have done in this slide. Now redundant is equal to this. Yes, strain energy se we have already derived this. From here I got that redundant ka value was 14.67. So what was redundant actually? It was HB. So the value of HB, which was asked us initially, that HB value is 14.67. And what is another use of this? Now we can find the force in any member in that statically indeterminate truss. So force in member AC initially in that statically indeterminate truss under the P system of loading is now equal to under the P dash system of loading, under when the statical determinate truss we were making and redundant we have removed whatever the force, and we have to use this also, the value of redundant, into what is the value of force in member AC when only unit load was acting. So I have found UAC also. This value was 0, redundant ka value was 14.67, this value was 0.75. We can see from here also 0.75, this was 0 and this was 14.65, it comes out to be 11 kilonewton. Since it's positive, it will be taken tensile force. So look, by using all these concepts, we found what was asked us in the beginning. So what was asked us in the beginning? It was asked that we have to find this reaction also, which was extra reaction. So we did all that to find this extra reaction, and when this extra reaction was known, we can easily calculated the force and member AC, which was also asked here. So this was 11 kilonewton tensile, and this was 14.67. so B and A part are basically the answers. Now you might be thinking, you know, this is a very lengthy question, it might not come in GATE, but the thing is, GATE is now moving to these kind of questions where you have to apply a little bit of concept and you have to do a little bit of calculation. It might happen, I mean, this question can directly come in ES, that's a very high possibility, but for GATE what can happen is maybe you can be given a like simple truss, a 3-member truss you might be given. So for that the number of steps would be a little bit lesser. So you already know the concept, you only had to move from the numerical part, and your calculation should be fast enough, so you can easily solve this question within 5 to 7 minutes. You know, these two question, linked question, so it might come for like 2 marks or 4 marks, it can be asked, and investing about 7 to 8 minutes for a 4 marks question in GATE exam, I think it's acceptable. So I mean, at least if this question might not come in GATE, but at least you get to learn the concept of this question, which is very, very important, and from here another question can be shaped also, okay, based on the concept. So concept is very important. I hope you get this. I understand that it is a bit lengthy and it is a bit confusing at times, but if you have any confusion, you can basically rewind the video and you can watch that step again. I will also provide you the PDF so that you can see that, you know, wherever what step led to which step, and how, from where we get this, and you can do the calculations yourself also in order to cross check it. So all the best for your future, and thank you. That's it from my side.